All right, so we're going into folder A for week 8. All right, so you guys start off with the ed puzzle, which goes over what we're about to talk about. There's a quizzes, which is kind of like, as always, it's a quick review. And then you got a discussion, which is going to ask you about these inequality signs. It's going to ask you, when do you use them and how do you use them? Do you use open dots or closed dots? Because that's what this is all about, inequalities. So before we get to the IXL assignment, this one here, we're actually in the graph. Let's briefly talk about those details. All right. Get a good marker. Okay, so if I have two numbers, 7 and 8. Well, in the past, we worked with equations, and the only thing you have for equations is an equal sign. Okay, that's the only symbol that we use for that, besides like plus and minus and that sort of thing. And if I have two numbers and I want to compare those two numbers, I can't say this. That doesn't make any sense, right? 7 doesn't equal 8. All right, so if anything, I put a line through it and I say it doesn't equal. But I also want to know which one's bigger. Well, if I was to use an inequality, then I would say the 8 is bigger, which means I would face the arrow towards the 8, but then the open part would be facing the 8. I'm sorry, face the arrow towards the 7 and the open part towards the 8, which says that 8 is larger or greater than 7. But if you start on with the 7, then you'd say the 7 is less than 8. Now, some of you guys might remember from like, middle school or elementary, maybe your teacher taught you about the fish. The fish always eats the 8, right? Or maybe it was like an alligator or something like that, right? You guys like my alligator? My little legs right there, like that. All right, so you always face the open part or the mouth towards the larger number, right? Now, we're talking about algebra or integrated math. And when we're dealing with integrated math, we're dealing with numbers that we don't know, okay? And that's really what algebra means, is unknowns, numbers that are not known. So if I see something like this, let's say 2x equals 4, you'd know how to solve that. I divide by 2 and divide by 2 and x equals 2. But I can also write this as 2x is greater than 4. And I end up actually solving it the same way. But the way I state my answer is different. So if I would like to solve this, which you guys will eventually do later on, then x equals 2. Here I do the same thing, but in this case, it doesn't say x equals 2, it says x is greater than 2. So the answer could be a whole bunch of different numbers, okay? It could be more than just 2. It could be any number that's larger than 2, okay? The other thing you gotta remember is that there's a second symbol, and that's the equal to sign. And when it says equal to, that just means that that answer could be that number. So x could be greater than 2, or it could be equal to 2. All right, so let's look at a few different statements. So in other words, if I have 7 and 7, what inequality could I put in there? Let me write the inequalities over here. Well, the only one I could fit would be these equal to sign. I couldn't do this because 7 is not less than 7. They're equal. They are the same. But if I put an equal sign, then that is true. That makes sense because 7 is equal to 7. Okay. Now, the question is, how do you graph this? Okay, because we want to describe what that solution could be. The solution in this case could be anything that is less than or could be equal to 7. All right, when well, let's say I solved an equation and this is what I got, right? Sorry, I shouldn't say equation. I solved the inequality And this is what I got. And the answer could be anything less than 7, or it could be equal to 7. So what I do is I bring up my number line, and somewhere on here I'm going to put 0, just so we know where the kind of the midpoint is. And then I got positive 7, so I'm going to go all the way to 7, 5, 6, 7. You know, I could write in all those numbers, but I'm not going to. And then on that line, some of you guys might remember this, I'm actually going to put a dot wherever the number is. So the number that we're talking about, 7, right there. Now it says that the answer could be less than 7. So that means that anything going to the left could be a solution or could be an answer. So when I'm actually graphing this, I just put an arrow going to the left. Now what if it looks like this? I'll move this out the way. What if it's x is just less? Okay, not equal to, but less. Okay, well, same thing. Start with 0, go to 7, and instead of putting that kind of dot, I'm going to put this open dot that's not closed, it's not shaded in. Okay, but then I'll do the same thing, because what this says is x can be less than 7, so that means that the answer could be anything to the left of 7. But the reason it's open is because what we're saying is the answer cannot actually equal 7. So anything that's less than 7, we're good. But the answer can't be actually 7 itself. So that's why we put the open dot. Okay. So moral of the story here, if you get a sign like that, you're going to use an open dot on your graph. If you get a sign with the equal sign in it, then you're going to use a closed dot. Okay, so what we're doing is you're going to take a statement, an inequality statement, and you are going to graph it, okay, with IXL. And then in some cases, you're going to actually be given the graph, and from that graph, you have to come up with this. Okay, so that's the two types of situations we're going to see in today's assignment. All right, so the first one, graph inequalities. So we're actually going to graph it. So again, always make sure you're signed in before you start these IXL assignments. All right, so x is greater than 1. So the solution can be anything bigger than -1. Okay, well, on the number line, first I start with -1. I just put a dot there. And it says anything greater, right? So anything greater than -1 will be to the right. Now, when you guys make these lines, make sure your line goes all the way to the end like that, to where that green part turns into an arrow. Okay, and you click there. If you made a mistake and you need to delete it, just click right on the line, just like in Delta Math, to delete it. Because sometimes maybe you guys might do this. That's actually incorrect because you didn't go all the way, and notice how it stops at another dot. So you actually limited your answer. You're saying the answer is between -1 and 1. Okay, but we know that the answer, it could be anything bigger than 1 all the way to the right. Now, the second part, again, is we got to look at the inequality sign. As we look back here, anything that's just less than or greater than, but doesn't have that equal sign, I'm going to use an open dot. But if it does have the equal sign, I'll use a closed dot. So on IXL, what you do to change the dot is you literally just click it. So in this case, there's no equal sign, so we need an open dot. And we just click it to open it up, and that's it. Okay, so here, I'll start with -6. So I put my dot on -6. And it says x is less than, so I go to the left, all the way to the end. And you can see here, it's got the equal sign, so that means it's going to be solid. So I don't leave it open like that, I leave it solid. Okay, so here, x is less than 6. So click on the 6. Less is to the left. And notice that there's no equal sign. So again, open dot. And then that's it. That's how you graph it. Basically, this graph describes what the answer can be. So, because when you're solving these problems, again, the answer could be more than one answer. It could be a whole bunch of, the answer could be 5, could be 4, could be 3, could be 2, could be 1, could be 0. Anything less than 6 works. But in this case, 6 cannot be an answer because it's open. Okay. All right, so a couple more here. So here, start at 9, and it's less. Now a shortcut to this, and again, that's equal to, so we got a close dot. A shortcut to this is that if you guys notice here, this inequality sign is pointing to the left. So because it's pointing to the left, then I know that my graph is going to go to the left. Okay, so anytime we're dealing with x is less than or x is greater than, we can, to kind of as a shortcut, just look at where the sign is pointing, and then that's where I want to point my graph. Okay, and that'll also show up when we do the tomorrow's assignment. You can also use that in that case too. Okay, so again, -60, x is less, so I go to the left. It's no equal sign, so it's open. And as you guys go through these, basically, the only reason it gets more challenging is because the numbers are bigger, but really it's the same thing. Okay, to the left, open dot, because there's no equal sign. Trying to get one that goes to the right. Okay, here we go. So now here, start at -28. And again, you can see that the arrow now is pointing to the right. So to make things easy, I just go to the right. Okay. So again, pay attention to the sign, which way it's going, how you read it. That will tell you which way to point. Okay. So that's really it for that assignment. Okay, so now let's go on to the next assignment, which is going to be write inequalities from the graph. So basically we're doing the opposite. So instead of starting with the inequality, we're starting with the graph, and then you actually got to write the statement. All right, so you can kind of use the shortcut to help yourself out. Now you always want to start with x, you're unknown, you don't know which number it is, right? Now you're at -1, so there's our number, because wherever the dot is, that's our number we're going to use. And it's pointing to the left. So it's pointing to the left, that means that x should be less than -1. Okay, less than. So it's either going to be this one here or this one here. Now, to determine that, I look at the dot. It's closed, it's not open, so it must be equal to. Okay, so x is less than or equal to -1. Okay, so we got another one. So now you can see it's going to the right this time, and if we're going to the right, that means that we're getting bigger, right? So that the numbers are greater than -1 this time. So x is greater, well, first it's a closed dot, so that means we're doing equal to, so greater than or equal to that same number, -1. Okay. All right, now we're going to the left. Start with x. And it's less than, so, and it's open. So less than, open means no equal sign, and then 2. Okay, and again, as a shortcut, you can kind of just look and see where the line is pointing. It's going to the left. So that means it's either going to be this one pointing to the left or this one pointing to the left. I look at the open dot and I notice that, well, it must be this guy because it's open and not closed. All right, so we'll do a couple more here. So x is, it's going to the right, so it's greater than, and is open, so there's no equal sign, so it's greater than -4. X is greater than -4. So really, that's it for this assignment. As you guys move on in points here, the numbers just get a little bigger, but they're not really much more difficult. Just remember that just because the number, especially for negatives, just because it looks like the number is bigger to the left, doesn't mean it's actually more. So when numbers are negative, the bigger the negative, the less the value. The smaller the negative, the greater the value. So that means that even though we're going to the right here and the numbers seem like they're getting smaller, it's actually getting bigger. Anytime we go to the right, whether it's on a graph like this or on this type of graph, right is more positive. Left is more negative, or less or greater, okay?